Alright, factorizing trinomials. We are now going to have a look at another method for factorizing quadratic trinomials, which is the cross method. The point of that method is that an attempt is made to go from the trinomial form directly to the binomial product form without going through as many of the intermediate steps as we did with grouping pairs. It tries to accomplish that by exploiting certain properties of these trinomials. So let's have a look at those things. So what we're trying to do is we're trying to go from this trinomial form into the binomial product form, which is, so of course we don't know what the coefficient and the constant terms are respectively for the binomial. So we just put in some placeholders. So we have px plus u times qx plus v. Yep. So we want to go from here to here, and we have to find out what p, q, u, and v are respectively. Well, if you compare it to our example here, as you can see, the first term, the coefficient of x squared is the product of the first term, the first binomials, and the second binomial's x coefficients. So p and q, p times q here, has to equal to 6. And similarly, the constant term of the trinomial is the product of the first and the second constant terms of the binomials. So first and second constant terms has equal to 6. Yep, so coefficient of x terms has to equal to the coefficient of x squared. The constant terms, the product has to equal to the constant term. And finally, if you recall here, the second x term times the first constant term plus the first x terms times the second constant term, these two plus these two has to equal to the middle term. So q u plus pv has to equal, so pv qu, this and this, they add up to the middle term. Yeah. And to find out what pq and uv are respectively, it will involve quite a bit of trial and error. And to expedite that process, the cross method is used. So essentially, we draw a cross. Of course, we'll have to find out with p, q, and u, v here. So obviously, p, q are the factors of the first x squared coefficient, and u, v are factors of the constant term. And when we multiply along the diagonals. So PV, QU. And when you add them, they have to be equal to the middle term. Yep. So obviously, let's try the two factors of 6 first, because PQ is 6, so PQ are either 2 and 3 or 1 and 6. So we try 2 and 3 first. 2, 3. Yep. And the next two terms here are also factors of 6. So once again, they are either 1 and 6 or 2 and 3. So fortunately, because both of these are positive, so we can say that both these two numbers have to be positive as well. So we end up with say, okay, let me think. So 3 and 2, positive 3 and positive 2. So let's try it. These are also factors of 6. So 2 times 2 equals to 4. 3 times 3 equals to 9. 3 plus, correction, 9. 3 plus 9 plus 4 is equals to 13. So we say 2x plus 3 equals to 3x plus 2. So 2x. So this is the coefficient of the first x. This is the coefficient of the second x. This is the first constant, and this is the second constant. And we move back into the equation. So that's basically it. And of course, because this is quite straightforward, it's quite easy to find out what these four numbers are. But it may not be so straightforward every time. So for example, with 7 squared minus 3x minus 4. Of course, once again, we have to find the cross where these two numbers multiplies to 7 and these two numbers multiply to 4. Well, this number times this number plus this number times this number has to be negative 3. So we have to find four numbers satisfy these conditions. Fortunately, 7 is a prime number, so there can only be two factors, 7 and 1. Now, these two numbers have to multiply to negative 4. So these two are factors of negative 4. And 7 times this number plus 1 times this number has to be negative 3. Yeah. So in this case, well, what are the two factors? What are the factors? Negative 4. So they can be either negative or positive. So things like 1, 2, and 4. So let's try, say, one here and 4 here, and it should be a negative 1 because 7 times negative 1 is negative 7. 1 times 4 is 4. 4 plus negative 7 equals to negative 3. So this satisfies this and works out. So all we say is this should be positive here. So 7x plus 4 times x minus 1. Yeah. If you can gauge what these four numbers are rather quickly, then it's a somewhat quicker method than grouping in pairs. But if you're not so sure, a lot of time could be wasted on trial and error. So for example, let's have a look at next example. So negative 48x squared plus 44x minus 8. Now, of course, once again, as you can see, the highest common factor between these three terms is negative 4. So we can extract it outside parentheses, we'll end up with 12x minus 11x plus 2. Sorry, x squared here. So once again, we have to use the cross method. We have to find 4 numbers. These 4 numbers, these two have to be factors of 12. So this number times this number will have to be 12. And these 2 numbers will have to multiply to 2. While this number multiplied by this number plus this number multiplied by this number have to be negative 11. Well, this is the tricky part because 12 actually has quite a few factors. So 1, 12, 3, 4, 2, 6, and so on. So what we can do is through trial and error. So let's try the first one. 2 and 6. 2 and 6. Yeah. So, and these numbers have to be factors of 2 because 2 is prime, so obviously it's 2 and 1. And we're trying to make negative 11 here. So most likely both of these two numbers will be negative. Well, let's try it. So let's try negative 2, negative 1, 2 times 1. 2 times negative 1 is negative 2. 6 times negative 2 is negative 12. When you add them, equals to negative 14. Of course, negative 14 does not equal to negative 11, so this doesn't work. Let's try another pair of factors of 12. So let's try 4 and 3. So 4, 3. Well, what we do, once again, factors of positive 2. So we have, say, negative 2, negative 1. Well, 3 times negative 2 is negative 6. 4 times negative 1 is negative 4. Obviously, when you add them, it's negative 10. So negative 10 is not negative 11, which means this is incorrect as well. And we have to make another attempt. So how about we switch the last two around? So once again, 4, 3, negative 1, negative 2. Now 4 times negative 2 equals to negative 8. 3 times negative 1 equals to negative 3. When you have the 2, they are equal to negative 11, which satisfy our condition. So we end up with negative 4 times 4x. So this is the coefficient of the first x, coefficient of the second x. And here's your answer.